In this video, we'll finish section 2.2 separable equations with four more examples. I just want to show you again some of the weird ones and some where it requires some identities. This one is like super important. If you're taking Calc 3 with me, we use this one quite a bit. But this is called a reduction formula. It gets us, the reason it's called reduction is it goes from a second power down to a first power, which is very nice when it comes to integration. All right, so this is a separable equation. Let's go ahead and rewrite it and get it there. I don't want to do in blue. Oops. dy dx is equal to cosine squared. This one looks very daunting. Squared x plus cosine squared 2y. So I can actually move things over. I can multiply. I get cosine squared of 2y, which I'm glad that became a numerator. And then I multiply the other side by dx. All right, so we have that. All right, and I'm going to go ahead from here and throw my integration in. This is kind of what I said I do in my homework, is I just jump straight there. All right, so this, if I'm using the identities, so let's go ahead and try that. I'm going to get 1/2 times, all right, and I get 1, oops, that's an eraser, 1 plus cosine, and then since it says 2x from x, and this is 2y, this becomes 4y. All right, so there is that. And it's still an integral. All I did was change using the identity. So notice that a half is on both sides, so I'm actually just going to drop the half after this line. So cosine, and this is just going to be a 2x, just like the identity. Right, I'm going to shrink these up just a bit. I'm sorry you can't do so. Maybe you're using a tablet and you can. All right, so the halves are just going to go away. So those are gone. So I'm just going to do the integral now. There is a u sub here. I'm just going to eyeball it. So this is a y. The half is gone because the half on both sides. Let me do that here. Half is gone with that half. All right, and then okay, I get y plus, and then the way I do this is I write down my answer, and I just kind of gotten good at eyeballing it instead of doing a whole u sub. So if I do this, and it's not going to be a cosine. Forgive me, it's going to be a sine. If I take the derivative of sine, I get cosine of that 4y, but the chain rule would put out a 4 from the 4y, so that's why I put a fourth. So I don't have to go through the whole sub. If you need to do u sub, please do so. But that is a quick way to do it. The same thing works here. Okay, I have an x, and then it's going to be a plus 1/2 sine 2x, and then plus c. I am not going to be able to solve this for y. It would get real gross because I have a y outside of sine and inside of sine. So if I do inverse sines, it's just going to, yeah, it's not going to work out. So that's a great answer there. Please get comfortable with these implicit solutions. I think it's like once I start telling students they don't have to rationalize anymore and they have that hard time and it like kind of hurts. Um, like you have to do it. You may feel that way in some of these, but literally this one's impossible. There might be some crazy way that I can't see. I'm not a know-all with all of it. So if you can find something to get it to solve for y, but I think I'd put money on it. All right, the next thing, this I guess it's called an identity, but an integral formula. This integral formula is going to show up quite a bit. Just like the arc sine, arc cosine, arc tangent. I have arc tangent memorized, but this one I don't. I had to go look at a table. So maybe just knowing things pop up quite a bit, you may want to get it in there. Okay, so let's take a look at this. I'm going to go ahead and write out the problem, changing that. And I got 1 plus y squared to the 1/2 power. Okay, if I were to move things around, I get 1 plus y squared. Oh, it's minus. 1 minus y squared to the 1/2 dy. And that's 1 over x, moving over here with our dx. All right, and then I know I'm going to take the integral of that. All right, so the left side is exactly why I brought up, oh, that should be a negative because I moved it over, right? The reason I brought up is because it's exactly this, right? A in this case is just a 1. So I'm going to follow that rule. This is just arc sine, and then it's going to be u over a. A is 1, so it's just arc sine of y, right? And then I don't do the plus c because I'm having on the other side. The integral of 1 over x is ln. of x? Absolute value. Please do not forget the absolute value is extremely important. This one we could solve for. I'm just going to take sine on both sides. And it's not pretty, but I can make it explicit. All right, so there's our formula there. The line above would have been fine. Usually that's what I would have went with because it just looks nicer. But either way. All right, a few more. A couple more. Here's our last two. All right, so this is an IVP instead. So how do I use an IVP to get down to an actual answer? So let's work on the separable part first. At 1 minus 2x times y squared. Okay, this is separable. I can see it, right? They're multiplied. I'm going to get 1 over y squared dy, and then 1 minus 2x dx. Right, and I can be lazy, which I'm going to be, and we could go ahead and just throw our integrals in there. One of these things with skipping work, like steps like this, if you're not seeing it or you struggle every time you're like memorizing why that's true, you probably should go through the steps, multiplying both sides one by one, writing it down, next line being an integral, but that's up to you. Okay, 1 over y squared is going to be negative 1 over y. Um, you could go ahead and do that, right? It's just y to the negative 2. And then this thing's going to be an x minus x squared plus c. Now, I don't touch these from here. Like, I'm not going to go ahead and try to solve for y by any way. What I'm going to use now is going to be my initial condition. Y of 0 is negative 1 over 6. So I'm going to plug that in here. I get negative 1. This is going to be a little tricky, so be careful here. Negative 1 over negative 1 over 6. So I'm going to write it that way because that keeps me from doing anything weird. All right, so I got that plus c. Those are zeros. So if I do that, the negatives cancel. 1 over 6 flips, and I get a 6. And then everything on the right just becomes c. So my actual answer is 1 over y equals x squared minus, sorry, x minus x squared plus 6. And if you really wanted a y equals, I guess you could have it. It's going to be negative 1 over that. Keep doing a square up front. If you would like either answer, like I said, I'm extremely lazy with that, and I don't see a benefit from going from the one right above that to that, unless you're going to go to a calculator, and I just don't like to rely on the calculator for all this stuff. Okay, so we have one more problem. Your notes may have been messed up. Hopefully, I just remember to fix them by the time I get them to you guys. But if I don't, go ahead and rewrite, put a dy right there. All right, so notice the difference between the answer we just came up with and the answers in the previous one. The answers were family of solutions in the previous ones because of that C. I could put whatever C I wanted there. But in this case, if it goes through an exact point, I have to solve and look for C like we did here. And then I have a particular solution. All right, so let's do this for this next one. Things are moved around. I think 4 is pretty close. I'm going to do one step at a time here so you guys can see it. I'm going to go ahead and bring this minus x dx to the other side. And then I got y dy. And then I need that e to the x to the other side. So I'm going to do minus x e to the positive x. I just flipped it. Okay. Now we're going to go ahead and do an integral. All right. On the right side, left side, sorry, I guess I don't know my left and right. I just get 1/2 y squared, no surprise. And then this thing is going to require integration by parts, or I use tabular. So let me show you what tabular, how that works, if you'd like to look it up. I wasn't taught this in Calc 2. I saw it later, and I agree with my professor that did not show it to me. This is a great tool to not grade during Calc 2. You really should work on integration by parts so you understand it, and then eventually use this. Okay, so this is a plus minus. And then I do a derivative, d dx, and then an integral dx. Those are my signals. And then what I'm looking for is, well, first this is going to be plus minus plus minus. What I want in this column here is I want the vanishing part of my integrand. What does vanishing mean? Vanishing means that eventually with derivatives, it goes away. So I'm just going to put an x. We'll keep that negative x out front, or the negative, I mean. This goes, if I take the derivative, I get 1. If I take derivative of that, I get 0. That's what I mean by vanishing. Eventually, derivatives go away. And then I put e to the x, and the reason we did that is that's really nice here, okay? E to the x, e to the x. Our answer, it's really nice. It's this, right? Let me use a highlighter because that'll be better. This times that plus this times that. And then you go all the way down until you get a plus 0. So I only get those two. And then I get to write the answer straight from that. So I get x e to the x. Oh, let's not forget our negative. So we'll put a negative out front so we don't mess it up. Okay, I get plus x times e to the x. So I get the same thing. And then I get minus e to the x. Cool. I think that's a great solution. You could flip them if you want. That negative out front does not bother me. So that's our solution. Oh, we forgot something actually here. I forgot my plus c. I was just ready to be done, I guess. So now I have to use the y of 0 equals 1. So 1/2 times 1 squared equals negative. And then we're going to put 0 here, e to the 0, minus e to the 0 plus c. Now be careful with those e to the zeros. On the left side hand side, I get a half. On the right hand side, that's gone times 0. But this e to the 0 is a 1. And it becomes a positive 1 because the minus minus plus c, which tells me that c is actually, if I minus that, I get negative 1/2. So my actual solution, this was a family of solutions. Now I'm going to write down the particular solution that goes through that point. And I just fill it in. I don't clean anything up because I don't want to mess it up. So that's just a half, and I am done. That's the answer that I want. All right. This section, I would really, really make sure you're good at because some of the other methods are you'll do something and then it'll turn into this. So this is one of those building blocks that if you leave this behind, nothing's gonna feel right for the rest of the semester.